Okay, guys. So I welcome you all to our live Linux training for members. In today's session, we will learn about the history of Unix or history of Linux. And in the upcoming days, I will show you how can you easily do the installation of RHEL 8 in VMware or on EC2 at Amazon Web Services. Then from the next session onwards, we will work with commands, because everything whatever we will do on Linux, that we will do with the help of commands. We will hardly use GUI there, and all the topics of RHCSA we are going to cover up with the help of the commands only. And here, as a Linux admin, we are only supposed to use the commands. Okay, so coming back to the point, today we are going to study about the history of Unix. Actually, Unix and Linux both are very similar. Linux has been invented with the help of Unix. So first we will know about Unix, because it is mandatory for us to know about Unix if we want to learn about Linux. So originated at a research project at AT&T Bell Labs in 1969 by Ken Thompson and Dennis Ritchie. So Unix was invented by a team where these two guys were there, Ken Thompson and Dennis Ritchie, in 1969. And it was developed in several different versions for various hardware platforms like Sun Sparc, PowerPC, Motorola, HP, and RISC processors. So these two guys were there in that team who invented Unix. But at that time, the storage devices were not as much good as we have nowadays. One minute, guys, let me check the feed on YouTube. Guys, can you please let me know if we are... One minute, guys, let me check the feed on YouTube. Can you see the live feed on YouTube? Please let me know.
Yeah, it's streaming.
Guys?
Yes, it's streaming on YouTube.
Yeah,
Okay.
it's streaming.
So these two guys were there in the team who invented Unix. So Dennis Ritchie is the same guy who was there for C language. And he was there in the team where the DOS was invented. Now coming back to the history of Unix, what happened in 1991? Linus Torvald, this is the guy who was there who created Linux. In 1991, Linus Torvald, while he was studying in the University of Helsinki, he created a Unix-like system which was capable of running on Intel 386 processors. Because at that time, Unix was very bulky operating system, and at that time, we were not having that much capable storage devices. And it was almost impossible for us to use such devices at our home. So Unix was nearly absent from the market. It was only used by the giant companies or some government projects. At that time, Unix was nearly absent. Commercially, people were not capable of using Unix. So there in 1991, this is the guy, Linus Torvald, who created Linux with the help of Unix. While he was studying in the University of Helsinki, he was working on a project. Actually, he took the kernel of Unix, and after making some modifications into it, he developed the new OS, and he gave the name to this OS as Linux. He gave this name because Lin is there in his name. So he gave first three letters of his name and UX for Unix. So this Linux was the operating system which was invented by Linus Torvald. It was similar to Minix, a Unix operating system. So with the help of the Unix, he invented Linux. Although he has only written 20% of the source code, while the 80% of the code was written the other guys in his team. But the credit goes to him and he kept it open source. Intel had already started dominating the PC market at that time, but Unix was nearly absent from the initial market because, as I told you, we could not use those devices. Those are very expensive and as well as very bulky. So at that time, it was almost impossible for a general guy to use Unix. In January 2000, Apple announced Mac OS X, Unix hybrid that provides Unix command line features. So Apple announced its OS that we use, Macintosh, in January 2000. It is also based on Unix. And your Android phone that you use nowadays, it is also based on Linux kernel. There you can use or execute almost all the commands that you can execute on a general Linux. There are many commands supported on Android as well. Now question arises, is the Linux same as Unix? So there are two answers to this question, yes as well as no. Why yes? Because it has essentially the same look and feel like any Unix operating system. And it offers the ability to run nearly any program that can run on Unix systems. Means if you want to execute any program which you were executing on Unix, you can easily execute that program on Linux. So that is why you can say that it is the same as Unix. But why it is not exactly the same? Because the kernel or the heart of the system has a lot of new features that go beyond the classical design philosophy of Unix kernel. Means Linux kernel is more advanced. So we can say that Linux is Unix-like operating system, but not exactly Unix. So you will say, if someone asks you whether the Linux and Unix are same, so you will say Linux is Unix-like operating system only. Generally, we use
a word GNU, which stands for GNU, not Unix. So if you will see the word GNU, that means Linux or Unix-like. GNU emphasized a major project for the Free Software Foundation that really created the Linux operating system with many of its popular tools. Richard Stallman created the Free Software Foundation in order to encourage the development and use of freely redistributable code. Actually, the source code of Linux is free. There you can make the modifications in the source code and you can create your own OS. You can add the features there in the OS. So Free Software Foundation is there for the development and free use of this code. Freely means the freedom of redistributing the code under the certain conditions. It does not mean the zero financial cost. Now we will talk about the flavors of Unix. So Unix is available in different flavors. Yes, hello? Hello? Where? On Google Meet. Where it is not visible? 1 minute. Is it visible now? Yes. Okay. Now we will talk about the flavors of Unix. So Unix is available in different flavors. Linux is there, HP Unix is there, IBM AIX is there, Macintosh is there, and Sun Solaris is there. So these are some flavors of Unix. But if I will talk about the flavors of Linux, Linux is available in lot of flavors. You can find Red Hat there, CentOS there, Ubuntu there, Linux Mint, Kali, Fedora, OpenSUSE. A lot of versions, lot of flavors are available for Linux. There are different communities who are creating their own OS and providing the support. So there are two major categories in Linux. One community is there that we call the Debian, and another one is the Fedora. So in Debian, we can have Ubuntu there, Linux Mint there, and in Fedora, we can have the Red Hat, CentOS, OpenSUSE. So these two major communities are there who are actually handling the different operating systems which are based on Linux. Now we will talk about the features of Linux. What are the features that we can have in this OS? So it is highly secure. Generally, we say that it is a virus-free operating system because there is no execute permission by default present in this operating system. That is why the viruses cannot execute there. So this is highly secure. It is highly stable, very easy to maintain, almost hardware independent, freely available. Distributed OS. Distributed OS means different flavors are available. You can choose the OS which is suitable for you. It supports almost all type of file systems. Multi-user, multitasking means multiple users can use the same OS at the same time. Open source means the source code is available to the user. They can make the modifications there and create some additional features. Very easy to use. It is slightly bit difficult in the beginning when you start working on Linux. But after some time, you will become expert. It is very easy to use after few days. Customization options are available. It can be used for educational purpose. Community support is there, and it handles the processes in a better way as compared to the other operating systems. If I will compare the Linux with Windows, I will prefer Linux because it handles the process in a better way on the same hardware. So these were some features of Linux. Now we will know where we can use it. So Linux is used in supercomputers, in space station, servers, cloud computing. You can find it in smartwatches, Large Hadron Collider, the machine which is running in Geneva, in-car entertainment, NASA, flights, space robots, smart cards, bikes, game consoles, ATC, smart TVs, stock exchanges, US defense, in your mobile phones that you use, nuclear submarines, laptops, desktops, PCs. So Linux is there everywhere. You can find Linux from an smartwatch to the supercomputers. Now I will talk about the Linux kernel. So what do we mean by kernel? Actually, kernel is the bridge. Kernel acts as a bridge between the user and the hardware. Whatever work we want to perform on the operating system, that is done with the help of the kernel. Let us suppose I want to increase the volume of my PC. So what I will do, I will drag the volume bar. So it will send a message to the kernel, and then kernel will send a message to the hardware that the user is wanting to increase the volume. So with the help of that, the hardware will amplify the sound. So kernel is there, which is working as a translator. the operating system is broken into three pieces: the kernel, shell, and the built-in utilities. So kernel is the core. Hardware is there in the middle, then there is kernel, and then there is shell. Because whatever work we will do that on shell. Shell is there where we will execute the commands, the instructions which we want to give to the OS, that we will pass with the help of shell. So shell will accept or take the command from us, and then the shell will send the message to the kernel, and then the kernel will do the same on the hardware. So kernel is there, which actually works as a bridge between the user and the hardware. So now we will talk about the Linux shell. What is shell? So shell is the program that is running behind the terminal. Let me show you. Let us suppose we are working on the Linux terminal. It is the Linux terminal, and on this terminal we are using the bash shell. This is the born again shell. So shell is the program that is running behind this terminal. This terminal is not the shell where I am firing the commands. The program which is running behind this terminal, which is accepting the commands from me, that is the shell. And there are multiple shells in Linux. We can use our own shell, which one we prefer. And this terminal is called the Linux terminal, and the program which is taking the commands from us is the shell. Currently we are using the bash shell. It is similar to the command line interface. Shell is almost similar to the command line interface or the command prompt that we use on the DOS based machines, like on Windows. On Windows, we call this command line interface as command prompt. And here we call this command line interface as the shell. It comes under different flavors, but all of them do the same thing in this slide different ways. So there are different shells that we use, like ZFS, TCSS. So these are some shells. We will talk about these shells in the upcoming sessions. So how can we use the shell? Two things are mandatory if you want to work on your machine. If you want to log in the shell. To log in the shell, you must have your user account on that particular machine. So for that, you must know your username and password. If you know your username and password and your account is there, then only you can log in into the shell and you can fire the commands there. Have a means of communication with the shell, so you can provide this kind of information there. You need to have your username and password with you. So how can you create your account there? You can ask admin or the root user to create your account on that particular machine. Only then you can log in the machine and use the shell. Now I will talk about the Linux booting process. We are not going through the booting process of RHEL 8. This is the general booting sequence of Linux, which I will show you now. In Linux booting sequence, the first operation that we perform is the power on self-test. Whenever we press the power button on our machine, then the post operation executes power on self-test, where the motherboard sends a signal to all the devices and checks if all the hardware is in the working condition or not. After getting the acknowledgement from all the components, it gives the control to the BIOS. BIOS is the basic input-output system, which is a hardware and software both. There is a chip in your motherboard which has a program in it. In current days, we are using UEFI. Nowadays, it has been replaced with UEFI. So BIOS and UEFI both works in the same way. In UEFI, there are some more features that you can use. You can use your pointer there to make the changes. You can customize that as well. while in BIOS only limited options are available. After that, BIOS checks for the master boot record. Master boot record is a 512 byte long space in the memory or in the primary hard disk, which contains the information about the grub or the Linux kernel. So after getting the control from the BIOS, MBR checks for the grub. Grub is the Grand Unified Bootloader. In Linux, we use the bootloader, which is grub or grub version 2. Earlier, we were using Lilo, that is called as the Linux loader. So after getting the control from the MBR, grub loads the kernel, then the kernel starts the init process, and then it loads the other components of the operating system. So there are different values of init with which the machine boots up. But this booting sequence of Linux is the general booting sequence. It is not the RHEL8 booting sequence. That is slightly different from it. I will teach you that in the upcoming sessions. There we don't use init. There we use systemd. Okay. Now let me show you. This is the BIOS chip. You can see this, and in this picture, this is the BIOS, where you can make some changes. So BIOS is a combination of hardware as well as software. BIOS provides us the option to choose a boot device, and then it gives the control to the MBR or to the master boot record. MBR, as I told you, it is a 512 byte long space in the memory. It provides us the boot selection menu to choose a particular operating system with which we want to boot up our machine. And we can deploy up to the 4 operating systems in the same disk, because there are 4 primary partitions available, and we have different entries in this for each. It contains the information about the bootloader, and then it handovers the control to the bootloader. Grub is a file. Grub is the bootloader, Grand Unified Bootloader that we use in Linux. Grub is a file that is located in the address /boot/grub, and the name of this file is grub.conf. Currently we are using grub2. The location is slightly different, but that is also there in /boot. The older version of this Linux bootloader was Lilo, Linux loader. The latest version is grub2. After getting the control from the MBR, grub then loads the kernel image. The name of the Linux kernel is VMLinux. It interacts between the machine hardware and the shell. After getting the control from grub, kernel loads its splash image. Then it loads the remaining components of the OS, and then it transfers the control to the init. Init is the first process in Linux, and depending on the value of init, the machine boots up in different modes. So there are different run levels in which our machine boots up, depending on the default value of init. Init 0, which is called as the run level 0, which means shutdown. Run level 1 or init 1, which means the single user mode without GUI and NFS. The run level 2 or the init 2, which means the multi-user mode without network. Run level 3, which means the multi-user mode with NFS. Run level 4 we generally don't use. Run level 5 that we generally use by default, where the machine boots up in GUI with network facility. And run level 6 or the init 6 is used to reboot the machine. But nowadays we don't use these run levels in RHCL8. We use targets. Instead of run levels, we have their targets, and instead of systemd, instead of this init, we use systemd there. Okay, so init has been replaced with systemd in RHCL8. So when I will teach you the RHCL8 booting sequence, then I will show you that what are the processes that take place in the booting sequence of RHCL8 and how init has been replaced with systemd. Now coming to the Linux file system structure. If you will compare Linux with Windows, in Windows, we have everything there in the C drive, like the program files, the Windows folder, or the user files. So everything is there in the C drive. Here, everything is there on slash, and this slash is known as root. And inside this, we have different directories with the name as bin, which we use for the system binaries, for the binaries, slash etc for the configuration system configuration files, slash sbin for the system binary files, slash usr which have the read-only user applications, var which contains the logs, dev which contains the device files, slash home which contains the user home directories, slash lib which we use for the libraries and kernel modules, slash mnt that we use for the temporary file systems mounting, slash opt that we use for the optional software and applications, slash proc that we use for processes, and slash root that is the home directory of the root user. So these are the directories that we can find on a typical Linux machine. So these directories you can find on different flavors. There may be one more or one less depending on the flavor, what type of flavor you are using. There you can find some more directories or some less directories depending on the flavor. Let me show you. This is the Windows subsystem for Linux. It is similar to Linux, and here if I will list ls-l/, so I can show you these directories there. These are the directories. Bin is there, which contains the binary files. Boot is there, which contains the booting files. Dev is there for the devices. Slash etc it contains the system configuration files. Home contains the user home directories. Lib contains the library and kernel modules. There is slash media, which we can use for the removable devices. mnt is there for mounting the temporary file systems. opt is there where we can install the application and the additional softwares. proc is there for the processes. root is the root user home directory. So you can find these directories on a typical Linux machine. 1 minute. Raghu. Hi Raghu. So guys, this was all about the Linux history and Linux booting sequence and Linux file system. Tomorrow I will show you how can you install RHEL 8 in your machine. If your machine supports virtualization, then you can download and install either Oracle VMware or Oracle VirtualBox or VMware. I have already installed the VMware virtualization software in my machine, and here I have already installed RHEL 8 and CentOS 8 there. If your machine is compatible, it supports the virtualization, then you can download and install either of these tools in your machine, and there you can install RHEL 8. Or if your machine does not support it, you can create your account there on AWS Cloud. I already have my account there, and you can deploy your machine and you can practice there from your mobile. You don't need to have the PC with you every time. So this is my AWS console, and here let me log in, and then I will show you how can you deploy the machines there. Tomorrow I will show you the installation process of RHEL 8. It's very easy. Here you need to go to this EC2. This is the module where you can deploy the machines, and machines are called as the instances there on AWS. On AWS, here you can deploy the machines. So there are no currently running machines, but I have already deployed these two machines there, and I can use these machines directly from my mobile. You need to have a terminal software installed in your mobile to access these machines. You can directly do SSH from your mobile. So I will show you both the methods. How can you deploy it in VMware and how can you deploy it on AWS. So guys, that's it for today's session from my side. If you have any queries, you can ask me. So for a while, I'm going to stop this broadcast on YouTube, but we will be there on Google Meet. Thank you so much for joining. See you guys